All right, we're in the Helicopter Flying Handbook, Chapter 4. Chapter 4, page 10 of 18 on an iPad or smart device. We're going to go into transmission systems. Transmission system transfers power from the engine to the main rotor, tail rotor, and other accessories during normal flight conditions. The main components of the transmission system are the main rotor transmission, tail rotor drive, system clutch, and freewheeling unit. The freewheeling unit, or autorotative clutch, allows the main rotor transmission to drive the tail rotor shaft during auto rotations. In some helicopter designs, such as the Bell BH-206, the freewheeling unit is located in the accessory gearbox. Because it is part of the transmission system, the transmission lubricates it to ensure free rotation. Helicopter transmissions are normally lubricated and cooled with their own oil supply. A sight gauge is provided to check the oil level. Some transmissions have chip detectors located in the sump. These detectors are wired to warning lights located on the pilot's instrument panel that illuminate in the event of the internal problem. Some chip detectors on modern helicopters have a burn-off capability and attempt to correct the situation without pilot action. If the problem cannot be corrected on its own, the pilot must refer to the emergency procedures for the particular helicopter. Main rotor transmission. The primary purpose of the main rotor transmission is to reduce engine output RPM to optimum rotor RPM. This reduction is different for the various helicopters. As an example, suppose the engine RPM of a specific helicopter is 2700. A rotor speed of 450 RPM would require a 6-to-1 reduction. A 9-to-1 reduction would mean the rotor would turn at 300 RPM. Dual tachometers. Most helicopters use a dual needle tachometer or a vertical scale instrument to show both engine and rotor RPM, or a percentage of engine and rotor RPM. The rotor RPM indicator is used during clutch engagement to monitor rotor acceleration, and in auto rotation to maintain RPM within prescribed limits. It is vital to understand that the rotor RPM is paramount and that engine RPM is secondary. If the rotor tachometer fails, rotor RPM can still be determined indirectly by the engine RPM, since the engine supplies power to the rotor during powered flight. There have been many accidents where the pilot responded to the rotor RPM tachometer failure and entered into auto rotation while the engine was still operating. Look closer at the markings on the gauges in figure 4-17. All gauges shown are dual tachometer gauges. The two on the left have two needles each, one marked with the letter T, turbine, and then marked with the letter R, rotor. The lower left gauge shows two arced areas within the same needle location. In this case, both needles should be nearly together or superimposed during normal operations. Note the top left gauge shows two numerical arcs. The outer arc with a large number applies one set of values to engine RPM. The inner arc, or smaller numbers, represents a separate set of values for rotor RPM. Normal operating limits are shown when the needles are married or appear superimposed. The top right gauge shows independent needles focused toward the middle of the gauge with color limitation areas respective to the needle head to the left to the needle head. The left side represents operational parameters. The right rotor operational parameters. Many newer aircraft have what is referred to as a glass cockpit, meaning the instrumentation is digital and displayed to the pilot on digital screens and vertical scale instruments. The bottom right gauge in figure 4-17 replicates a vertical scale instrument. The dual tachometer shown displays rotor RPM in R on the left side and the engine RPM in P on the right side of the vertical scale. Corresponding color limits are present for each component parameter. Yes. Cool. All right. So we'll hold off there. It's 4 minutes into there. So that was page 10, the transmission system, tachometers, main rotor transmission. Now we'll go on to page 11, structural design. See ya.